Hey, this is Ken from Maker's Box, and today we're going to put together a geek spinner kit. Try and convince you that it's easy to do. So I've got some lid-free solder from SparkFund, got some solder braid if we need it, I've got some Hecko flush cuts and some needle nose. I'm using a Hecko FX888, one of my favorite irons. We're going to need 4 nickels or 4 quarters to help early on, and then when we're all done we're going to need a battery to turn this thing on. So let's take a look first to make sure we got all the parts. Try my best to make sure that everything's in there. If it's not, send me a shout out. So we've got 8 resistors, so I've recently just switched from 330 ohm to 100 ohm because with the battery they show up better. Got our PCB, got our bearing, got 9 LEDs. I put one in there extra in case you want to play with it or in case you need to replace one. We've got the printed caps, and I've already put the magnet in there. It's actually kind of hard to do to get it in right, so I've been taking care of that. We've got the pre-programmed AT1084 capacitor switch. Got our battery holder, and then our Hall effect sensor. So good, looks like it's all here. Alright, so I usually work from lowest to highest on the board so that I can solder and hold things in place easiest. And that's usually the resistors, since it usually fits on the board. So I usually use my needle nose. It's just kind of a trick. You can tell I built a few of these here, so get them all bent like that, and just depends on how trying to do this working with the camera in front of me is not the easiest, but we're gonna do it. So you're seeing this from my point of view. I usually like to have the color codes all the same way, just kind of the perfectionist in me. It doesn't really matter so much with these 100s because they're kind of mute colors, but with the 330s they're bright orange floating everywhere. Getting them flush in. The reason I like to start with resistors is because there's no polarity, so you don't have to worry about getting them in the right way. They're also fairly heat resistant. So you can usually the first couple of solder joints I do, it takes a while to get your groove on, and resistors give you a chance to do that. So those are all in nice and flush, and if you wanted to you could spread the legs out, kind of hold them in place. I usually just rely on the work surface to do that. Alright, my iron's up to temperature. I'm using lead free. Got my iron set at about 375 Celsius or 450. I'm sorry, about 750 Fahrenheit. It's usually about where I go. It's not going to be a soldering tutorial, but I'll give you kind of the lowdown. I'm using a chisel tip. Come in, touch both the lead and the pad, and I count to about 1,000, 1,000. You add a little bit of solder, and you get that nice tinted flow. You're not going to be able to see it, I think, from this angle. I'll see if I can get it closer here in a second. And I'm just going to work my way down the row. It's kind of magic when you see it, when I'm teaching people to solder for the first time, when you see that just wick in and flow in perfectly. And of course it's hard to get it perfect, and we're just hobby solder here. Nobody's going to be inspecting this work. We just really need it to work. So there's one side, and this is usually just about finding the angle. It's the easiest for you to get. It's all about getting that heat flow to both the component lead and to the pad, and then of course bringing the solder in and pulling it away before you pull the iron away, so you don't get hooked in there. It's easy enough to do, and I do it quite a bit myself. Okay, like I said, so these are 100 ohm. We were at a maker fair and we were outside and you could barely see the LEDs, and My initial theory was that 330s were good just for the battery life, because it would that reduces the current quite a bit, but if you can't see it, it's no fun. So we're got them to 100 ohms here, and I don't think my camera can focus that closely. A couple of these have a little extra solder, and then I'm using my Hatco. Boy, I just love the daylights out of these. Are only like $6 on DigiKey. These are flush cuts, so with the flat coming in, just trimming them flat. This is actually meant to be handled, you know, fidgeting, spinning, so I'm going to come in and clean up these joints the best that I can, just so that it's got a good feel to it. I don't, you know, usually wouldn't worry too much if there's pokies hanging off the bottom, but this is going to be in your hand, so I'll come back and hit those again with solder, and leads are done. So there, we're on our way. Oh, you can see I got one that's kind of, you know, nothing's ever perfect. Okay, so the next, as far as being height-wise on this, is probably the chip itself. So the AT-Tiny85, there's a divot in one end. Sometimes it's a dot. This one's got a divot. And if you look at your silk screen here, there's a divot on one end too. This is the one you got to get in correctly, or this will not work. So a lot of times if I haven't, you bend the leads over flat so they're at 90 degrees. When they come out of a packing tube and stuff, they're kind of splayed out a little bit. I may have already done that for you when I programmed these. So this should just pop right in here, sits down, and there we go. So I'm double checking orientation, and then on multi-lead components, I always suggest to solder in just a couple of them, and then double check and make sure that first that it's sitting flat on the board, and it is, and then double check the orientation. It's kind of hard on this, the silk screen's under there, but I know that pin one is the pin one. So once you get more than two solder joints in there, it gets exponentially difficult to undo your work and redo it. So I usually would just end up like clipping the leads off the component and getting a new component, because it's that hard to desolder something multi-lead. That's one of those stitch in time saves 9, so inspection in time saves a lot of pain. And you can see as I'm working here, right there is the ISP programming header for if you want to reprogram this thing. Okay, so these leads stick out. Normally I don't think I would mess with those, but since again we're going to be feeling this in our hands as we're spinning, I want everything as flush as possible. You know, doing this with the camera from these really messed me up. So I missed a joint there, and I see a little bit of gold. So those are things we want to stay on top of. So I'm going to add a little bit of solder. Just can't quite get as close as I normally am when I'm doing this, but that's alright. I like a challenge. Okay, chips in place. So probably the next highest things here. I'm not sure I'm following the instructable perfectly, but we've got our button, and we've got our capacitor. So the capacitor is just for power smoothing when you're popping LEDs on and off. If you had an oscilloscope on the voltage line, you'd see lots of little quirks and dips, and if it gets too close to the minimum voltage for the microcontroller, then it'll start causing like spurious resets. So a little capacitor makes life easy for us. Trying to do things by the book here. You can get away without it, but then when crazy things start happening, you're not quite sure what's the story. And again, I'm not doing a real great job on this, but you'll get the point. Alright, these push button, tactile push buttons go in. Pop that in, check the leads are through. Sometimes those leads get bent over. and that's never any fun. Okay. So the push button's used to provide inputs, so you can switch modes around. It's just a user input, so if you want to reprogram it to do something else. I always like to have inputs and outputs. Outputs on this are LEDs, the input's the button, and of course the magnetic Hall switch is another input. Okay, I think next on our line, so we got the battery and the switch, and those are both about the same height. Okay, so we're going to go with the switch here. So this is a single pole dual throw, even though we just need the single throw SP, single pole, dual throw. Yeah, I can never get those right. But anyway, I like this switch just because it's low profile, even though we're only using it on one of the poles. Single throw, dual pole. And this one's legs have gotten a little bit. There we go. So we got flush. Hold it down. And again, this is a multi-lead component, so I'm going to double check, make sure it's seated. I like that, so we're going to go ahead and finish up. Okay, and then the battery holder. So it's a little hard to tell from the silk screen, but there's a little curve to this bottom edge. There's one edge you can get the battery out from. One of the reasons I placed it that way is because usually when you're spinning, you're hitting it downward to spin it clockwise, and the forces will throw the battery against the retainers. Other than that, if you do put it in backwards, it's not a big deal, but there are some rhyme and reason here. These battery holders are a little tricky to solder because they're basically a big old heat sink. They've got all that flat metal on the back, so they'll suck that heat right out, so you need to add a little extra. Looks like we got it flat and seated, so I'm going to go ahead and nail that in place. Takes a little extra heat. Okay, we can clean this end up. I've tried using like a Dremel to kind of grind down the pad sometimes, and that you run the risk of trying, if you hit the board, you're going to wipe out the traces, so don't recommend that. I think just if you get them the best you can, because you're going to be feeling like that. This is probably the most tactile project I've ever looked at. Okay, we are getting close. Let's throw some LEDs in here. You usually get to select a color, or you can pick Surprise Me, and I'll just throw in a color. This one I've got blue in mind. So LEDs do have a polarity. Long leg is positive. Silk screen should have a positive, and the square, usually on a component, the square lead is the positive pin too. Not always, usually. And you can solder these in one at a time. I like to go for broke. And I got a couple of tricks I'll show you. So, and again, we're going lowest to highest, so you can see these are sticking up higher than, just a little bit higher than the button. And again, I did leave one other out. If you got a young one with you, you can play around and learn a little bit about batteries and polarity, and you can show them how it all works one way, and then you got a spare if you need it. Okay, so one about doing them all at the same time is you can look down there and see, yep, you got them all aligned, so they're either going to all be right or all be wrong. And we double check the positive to positive, so they're going to be all right. Or as Matthew McConaughey would say, alright, alright, alright. Okay, now this I've never really got a good way to do this. You can kind of see how they shift around a little bit. I like to see them sticking straight up because that means they're fairly well aligned. One of the things I like to do is just the one side first. That lets you double check that they're seated good, and it makes it easier to seat them if they're not. It also lets the component cool off a little bit. These are probably the most heat sensitive part on here, and so if you're a little unsure of your soldering and you're on there a little longer than you think you should be, just come off and wait a minute, let the component cool down, maybe save its life like so. And now I'll come back and look, and this is actually a pretty good one. They're fairly straight. If they're not, come in, I'm pushing down the top, and we'll come in and hit with the iron, and you'll feel it seat itself in there just right. And yeah, these are, like I said, I thought about making a little jig for this, but then I'd have to sell the jig too, and this thing is already on the expensive end for a hobbyist to buy. I always struggle with how to price these. You know, you want to make them so everybody can afford them because they're super cool, but I gotta keep the bills paid or Mama's not happy. Alright, so that's fairly, you can struggle with that for a while, but as long as you can get them all in a fairly straight row, it's going to look okay as it spins. And then we'll just come in here and knock these out. Time to insert the Benny Hill music and go to fast speed. Okay, resistors and capacitors and LEDs and still smoking quite a bit. Okay, so we've got just a few items left here, and this is probably the most challenging part at this time. So I like putting in the bearing next, and then putting in the Hall effect sensor so that you can kind of gauge the height of the sensor so that it matches up with the magnet. So there's the magnet, so we're talking about trying to get that set correctly so you get the most sensitivity there. So bearing time, this is probably the most challenging part of this whole assembly here. So we're trying to get this, we want this is really just held in by a giant pad is what that is. It's got silk, or it's got the pad on both sides, and we're going to solder that. And the thing I've found, and you may come up with something better, is that just 4 nickels to kind of hold the spacing for me on the bottom, and then I'm going to solder two places on the side here. Now, I talked a little bit about the battery being a good heat sink. This bearing is just a big old chunk of metal, so it's going to be quite a deal. And I usually just crank my iron all the way up, take as much heat as it'll give me. The other trick I have is to use a little bit of flux, and that'll help with getting a clean surface going. That'll help a little bit with getting that. The chisel tip here helps quite a bit because you can get a flat end on there. If you're really struggling, you could go to some leaded solder, which would let you lower it's got the lower melting point. I'm going to come in there and just letting the heat flow for a bit, maybe add a little bit of solder to help transfer heat. And other than that, it's just a lot of patience. So I'm starting to see it flow a little bit on the bearing shell. Bringing in some more. You want to be careful about what kind of surface you're on, because your gonna put some heat in your table. Yeah, trust me, I've destroyed more than a few tablecloths. So there I can see it's flowing on both the shell and the pad, so I'm going to be happy with that. And we'll come off the heat and let it cool down a little bit. And I'll give you kind of a closer look. So it doesn't have to be perfect, but you're looking to make sure you get flow on both surfaces. You know, you got a good adhesion. This is kind of extreme soldering here. This is more brazing than anything else. So coming in on the other side, same thing. And I usually go for two. We don't have to be, get too much solder in here. We're just looking enough to kind of tack it in place. And on two sides, and then we'll kind of offset the other pads on the other side. So there's a good flow. I like that. And this is probably going to be frustrating. I've done quite a few of these, so I'm kind of getting it down, and that's kind of the reason I want to give you a video, so you can kind of get a feel for it. Can be done. Just looking for some patience here. So flip it over. I'll just probably go a little bit diagonal here, give a little bit of offset to where the solder joints are. I have had an original fidget spinner I built prototype. I just soldered one side and it got dropped, and it peeled the pad away from the board, and so it is possible to lift the pad. So that's, if you do it on both sides, then you've kind of got opposing fastening kind of going there, so that should help you. Of course, it helps if you don't drop the fidget spinner too, but we're fidgeting, so it happens. Okay, I like that. It's in there. Be careful. I mean, it's still pretty hot, especially the outer ring, but you can get in there, and you're spinning now. And liking the low, looks pretty good. Alright, so with that, just letting that cool down. Next part we're going to do is put our caps in here, and they're made of plastic, so we don't want to melt them. Alright. Okay, so home stretch here. Hall effect sensor. I'll get that out of there. I might be able to focus on here. So the package on this is fairly slim, but you can see like a transistor. It has a smaller face that has the lettering on it, so that's the one we want facing towards the magnet. And we'll grab our thing here. I'll throw the shell with the magnet on there, and then we can feed this guy in. And you can see on the silk screen it shows okay, so we're looking to get this down flush. Again, we don't want this kind of snagging on anything, so the lower to the board we can get, the better. At the same time, we're wanting it kind of facing the magnet, so that looks good to me right there. We're kind of a little bit below the top of the cap, and a little bit above the edge of the bearing casing. So let's throw a single solder joint. Usually I think I pick the middle, lead, not have it much. There we go. And now we can come back and double check and make sure we're kind of square. Okay, I'm liking that, so let's go ahead and finish that off. And okay, so we'll that center lead there is actually connected to ground, which is part of the bearing pad. So if you touch the center to that, it's okay. The other two have to be separate. It's the 5 volt or the 3 volt supply on the analog signal. And by golly, I think we're ready for power. Moment of truth. So coin cell, there's usually a plus on the back, and that's the upside on your thing there. And these switches usually come in the opposition. Oh good, so you saw it spin up. So it's not going to do anything because we don't have the cap unless you get to, let's see, what is it, D5 is the pattern, so it doesn't need the Hall effect sensor. So that's the first thing to do is if you're troubleshooting is go to the D5 pattern and make sure. So all our LEDs are lit, which is a good sign. And now if we throw our Hall effect sensor, our magnet on here, now we should be in. Alright, let's go to, let's see, what am I doing? I'm spinning the wrong way here. So yeah, with the Hall effect sensor, it's got to spin clockwise. And then of course the orientation of where the magnet is affects it as well. So I got the magnet sticking down there. And the camera's not picking that up too well, but your eye does much better. So there's Hello World. So if you program it, you can change that to be whatever you want, or if you ask me to custom program it, I'll do that. It's measuring the RPM. I'll probably do another video about how the RPM stuff works because it's pretty fascinating and it gives you some insight into how fast the Arduino can go. And then count the number of revolutions. And then your total odometer, so it's pretty fresh here, 400 revolutions. I've got some that are up like 38,000, so it'll be interesting to see the life of your Arduino. Of course, the pattern we saw, and then there's two kind of patterns I put in there. There's a heart and smiley face, and I've got some instructions on how, if you want to reprogram it, how you can design it and code it so that you can get your own pattern in there. Alright, so hopefully that didn't scare you off. There are a couple tricky parts. I've tried to make it as easy as possible, and you can see it didn't take too long and you didn't hear any cuss words. So again, this was Ken from Makersbox. I appreciate you watching and I look forward to hearing from you. Thanks.